it's time we started practicing some 3 operations and brackets mixed together. So, what do you notice straight away? Well, hopefully you notice that 3 multiplied by something doesn't make 5. So what we saw in part 4, which was that there are different ways you can go about dealing with expanding brackets. That is going to make us want to choose this solution, which was the expand the bracket route. So let's do that now. 3 times 2x is 6x. 3 times 1 is 3. Okay, now we're going to look at our order of operations. We've got an multiply and we've got an add. So I'm going to subtract and then divide. Subtracting 3 leaves me with just 6x, and it leaves me with 2. Then my divide, well, it takes me back to x. What shall I put over here? Well, 2 divided by 6. I think that's probably better written as a third. When you divide in solving equations, leave as a fraction. There are some numbers you have to divide by that would give you very difficult decimals. Take, for example, 1/7. 0.142857 recurring. Now, if you want to remember all of the difficult decimals, that's fine. But I would strongly advise you to do less work and just leave it as a fraction. Okay, next example. Okay, so let's deal with this bracket and look, 5 and 50. So, cover that up. Imagine it says 5 times something equals 50. So the something is 10. So when we divide by 5, the something is 10. Okay. Indices and addition. Now, we haven't seen indices yet. Brackets were confusing because they sometimes meant we did change the order, so to speak, of our operations. Will that happen here with indices? Well, I know I can get rid of this add 1 by subtracting 1. That will leave me with x squared equals 9. That separate term is easy to resolve. So what that tells me is indices does still obey the rules. That's good. That makes the whole of that section definitely follow our order we like. Now the indices. Now, the opposite of squaring is to square root. So when you square root both sides, you get x equals 3. Be careful here though, please, because some operations are more complicated than others. 3 times 3 equals 9. Can you tell me another multiplication sum that makes 9? But you think about 3 times 3 when you do it. You might want to say 9 times 1 or 2 times 4.5. Those are good ideas. Did anyone say minus 3 times minus 3? If you did, well done. So actually, the answer here needs to be plus 3 and minus 3, which we write in that manner. So 2 key things from this question. Indices fits nicely within our rule. And then when we get a situation like x squared equals 9, we have to be careful. So x squared equals 16 would give me what for x? Plus or minus 4. What about x squared equals 1? Plus or minus 1. Does this work for cubed? Well, 2 times 2 times 2 makes 8. But does minus 2 cubed? Oh, minus 2 cubed makes minus 8. So what we've got here is a rule that works for x squared. So let's clarify our 2 rules again. The I in BIDMAS can be reversed just the same, but be careful with x squared. It isn't the same for x cubed. In the next part, we're going to continue looking at 3 operations, because there are many more variants you may want to see.